The control costs process is concerned with controlling, managing, forecasting, and analyzing project costs. It begins as soon as the project budget is approved, and the major activities are proactively influencing the factors that can lead to cost changes, monitoring and reporting, managing approved change request and making sure all budget components reflect those changes, analyzing variances, even beneficial variances, determining their causes, and documenting them as lessons learned, monitoring variances and performance trends and making requests for corrective or preventative actions, forecasting project costs, control costs, inputs. Project management plan. The project management plan includes the cost management plan, which describes how project costs will be managed, reported on, and controlled. The cost performance baseline is also part of the project management plan, and it is to compare actual costs to planned costs. Project funding requirements. Project funding requirements refers to the entire estimated cost of the budget, including any contingency or management reserves. It is to compare actual costs to planned costs. Work performance information. Work performance information is any data that can be considered related to the work which produces the project deliverables. Examples are schedule and progress status information, budget and cost status, quality status, estimates to complete, resource utilization information, and lessons learned. Organizational process assets. Organizational process assets are the source of existing policies, processes, organizational data and knowledge. The organization may have cost-related policies, procedures, and reporting methods that must be followed. Control costs, tools and techniques. Earned value management. Earned value management mathematically measures the performance of the project and provides formulas that forecast future results. It also provides a way to forecast future performance based on what's happened thus far with the project. Forecasting. Forecasting involves predicting future performance based on historical work performance information and expert judgment. EVM provides forecasting formulas. To complete performance index. TCPI. TCPI is a formula that provides the level of performance that must be achieved to meet either the budget at completion (BAC) or the estimate at completion (EAC). Performance reviews. Performance reviews are assessments that analyze the project historical cost performance. It can include earned value measurements, variance analysis, and trend analysis. Variance analysis. Variance analysis compares expected cost performance to what is actually occurring, and determines the causes of any variance uncovered. Variance analysis also makes a determination whether requests for preventative or corrective actions will be made. Project management software. Automated tools can help in monitoring, tracking, and reporting on earned value measurements. Control costs. Outputs. Work performance measurements. This includes work performance information that specifically provides mathematical measurements of performance that is communicated to stakeholders. It may also report on earned value values for WBS components or control accounts within the WBS. Budget forecasts. Forecasts on the project expected completion cost and variances is documented and provided to stakeholders throughout the project. Organizational process assets. Updates. Updates to the organizational or institutional knowledge base occurs as part of cost control, including lessons learned, corrective actions taken and the reasons, and the causes of financial variances. Change requests. Changes to the cost baseline or any component of the project management plan may be needed as part of this process. Project management plan updates. Approved changes will impact the project management plan. The most likely component subject to change is the cost performance baseline, project document updates, lessons learned, basis of estimates, and activity cost estimates are project documents likely to undergo revisions. Cost control system. The project cost change control system provides the processes and procedures for requesting, logging, reviewing, and implementing cost changes. It is a component of the project change control system, and since most project changes have a cost ramification, it's important for the cost change control system to be well established and communicated so that everyone knows the procedures to follow. Some projects will require a very extensive, detailed, and rigid system of change control, while others may not have a need for a cost control system that distinct from the project change control system. One of the project manager's most important cost control functions is to proactively influence the causes of change, and this includes discouraging unnecessary changes that will impact costs. This is not to say that projects should have no changes, but only such unnecessary changes must be deterred. Earned value management. One of the most common cost control techniques is earned value management (EVM). Earned value provides a consistent method for monitoring project cost and schedule performance using budgeted work and actual work completed as its basis. Earned value analysis is useful because if the project manager only focuses on work completed versus planned work completed, or on actual project costs versus planned project costs, the project may appear to be on track and healthy when in fact it's behind schedule or over budget. Because all earned value formulas are closely tied with the schedule and aggregated budgeted activity costs, earned value formulas provide measurements that when taken regularly can identify trouble spots early and give the project manager enough time to take corrective actions. Earned value measurements are taken routinely throughout the project, usually at predefined periods, such as monthly, but generally only after about 20% of the project's work is completed, because the EVM measurements are helpful only after there's sufficient data from execution activities. Earned value analysis can also be used to provide performance information for phase gate decisions, such as whether to continue with the project or not. In these go-no-go decisions, costs already incurred by the project are called sunk costs, and though tempting to use as justification for continuing a project, sunk costs shouldn't be a factor in those decisions. The earned value measurements help identify what project components are not performing as planned, but they will not identify why. So we have to find out the causes of those variances, even if the variance is beneficial. No project performs perfectly as planned, so EVM values that are regularly reported as perfect are probably an indication that something is awry with the calculations or underlying data. In our study of the earned value formulas, we're going to use the following example throughout. 4-month project. Total budget $110,000. Project cost at end of month 3. $95,000. Estimated work complete at end of month 3. 80%. Actual work complete at end month 3. 75%. Earned value core formulas. Earned value core formulas are: budget at completion BAC, actual cost AC, planned value PV, earned value EV, budget at completion. The budget at completion BAC is simply the total budgeted cost of the project. In our earned value example, the budget at completion is $110,000. The BAC is the aggregated amount of the scheduled activity cost estimates. Let's say that our sample project is made up of 5,500 hours of work at $20 per hour. Our BAC was arrived at by aggregating those activity costs. $20 $5,500 equal $110,000. Actual cost AC is the expenditure spent thus far or at a specific point in time on the project. There is no formula for actual cost. In our example, our actual cost at the end of month 3 is $95,000. Actual cost is not only the hard expenses incurred by the project. Actual cost will include the soft internal or indirect expenses of the project. For example, in an organization that is not projectized and that does not establish a general ledger for projects, the labor costs of internal personnel will not be directly charged to the project. The project manager will have to use some method, such as the time worked by these project team members, to create an actual cost that can be used for earned value measurements. Planned value. Planned value PV is how much work was expected to be completed. Planned value is shown as a monetary value based on the project's BAC. There are alternative methods that show planned value as a unit of time compared to the project's estimated hours, but the PMP examination questions will only present planned value as money. The formula for planned value is PV equal planned % complete multiplied by BAC. In our example at the end of month 3, PV equal 80% multiplied by $110,000. PV equal $88,000. Earned value. Earned value EV is how much work has actually been completed. Just like planned value, it's shown as a monetary value based on the project's BAC. The formula for earned value is EV equal actual % complete multiplied by BAC. In our example at the end of month 3, 75% of the scheduled work has been completed. EV equals 75% multiplied by $110,000. EV equal $82,500. Earned value variance formulas. Variances from the approved baseline will be monitored. Cost variance, schedule variance, cost variance. Cost variance CV shows how the cost of the project is comparing to the value of work completed. It does this by calculating the difference between actual cost and earned value. A negative CV result indicates that the project has spent more than what was expected. The formula for cost variance is CV equal EV minus AC. In our example at the end of month 3, CV equal $82,500 minus $95,000. CV equal negative $12,500. This negative cost variance shows us that our sample project is running over budget. Schedule variance. Schedule variance SV tells us how well the actual work performed compares to the planned schedule. It does this by calculating the difference between earned value and planned value. A negative PV result indicates that work on the project is behind what was scheduled, while a positive value indicates that work is ahead of schedule. The formula for schedule variance is SV equal EV minus PV. In our example at the end of month 3, SV equal $82,500 minus $88,000. SV equal negative $5,500. This negative schedule variance indicates that the amount of work actually completed is running behind what was scheduled to be completed. Earned value performance formulas. Earned value performance formulas are Cost Performance Index CPI, Cumulative CPI, Schedule Performance Index SPI, Cumulative SPI, Cost Performance Index CPI. The Cost Performance Index CPI shows how much work is being completed on the project for every unit of cost spent. A CPI of below 1 indicates that the project work is costing more than expected, while a CPI of above 1 means the project work is being completed at a lesser cost than originally expected. The formula for the Cost Performance Index is CPI equal EV divided by AC. In month 3 in our sample project, we have an actual cost of $95,000 and an earned value of $82,500. CPI equal $82,500 divided by $95,000. CPI equals 0.868. For every $1 inch cost, our sample project is earning only 87 cents inch work output. Cumulative Cost Performance Index (CPIC). The Cumulative Cost Performance Index (CPIC) provides a more accurate overall performance index for the project based on earlier CPI measurements. Rather than just being focused on one point in time, cumulative CPI uses the aggregate of the previous EV and AC measurements. The formula for cumulative CPI is CPIC equal EVC divided by ACC. In order to see cumulative CPI, let's assume that we have earned value measurements for the previous 2 months in our project. CPIC equal $165,000 divided by $172,000. CPIC equals 0.959. Schedule Performance Index (SPI). The Schedule Performance Index (SPI) shows how close actual work is being completed compared to the schedule. It's similar to the CPI in that a SPI of below 1 means that the project work is going slower than expected, while a SPI greater than 1 means that project work is being completed faster than originally expected. The formula for Schedule Performance Index is SPI equal EV divided by PV. In our example at month 3, its planned value is $88,000 and its earned value stands at $82,500. SPI equal $82,500 divided by $88,000. SPI equals 0.938. For every hour we originally estimated, our project team is actually completing only 0.94 hours. Cumulative Schedule Performance Index. The Cumulative Schedule Performance Index (SPIC) provides a more accurate overall performance index for the project based on earlier SPI measurements. Rather than just being focused on one point in time, cumulative SPI uses the aggregate of the previous EV and PV measurements. The formula for cumulative SPI is SPIC equal EVC divided by PVC. SPIC equal $165,000 divided by $159,500. SPIC equal 1.04. Earned Value Forecasting Formulas. Earned value forecasting formulas are: Estimate at Completion (EAC), Estimate to Complete (ETC), Variance at Completion (VAC), To Complete Performance Index (TCPI), EAC Situational Formula. Estimate at Completion (EAC). The Estimate at Completion (EAC) formula forecasts the total cost of the project based on current project performance. There are at least 20 different ways to calculate estimate at completion, and some of those different formulas are based on unique situations. Those alternate formulas are shown at the end of this chapter. But the easiest formula and the one we'll most likely encounter on the examination is the project's estimated budget at completion divided by its cost performance index. If cumulative CPI is available, it can be used in place of a single CPI measurement. The formula for estimate at completion is EAC equal BAC divided by CPI, or EAC equal BAC divided by CPIC. In our example at month 3, our budget at completion is $110,000 and the CPI is 0.868. EAC equal $110,000 divided by 0.868 EAC equal $126,728.11. This tells us that when our project is completed, its total cost will be just under $127,000. Estimate to complete ETC. The estimate to complete ETC formula forecasts how much more money will be required to finish the project. As with the EAC, there are some alternative formulas that can be used based on differing situations. A common formula for ETC is ETC equal EAC minus AC. In our example at month 3, ETC equal $126,728.11 minus $95,000, ETC equal $31,728.11. Based on current performance, our project is going to take just under $32,000 to get it finished. Variance at completion (VAR). The variance at completion (VAR) predicts what the difference between the budgeted project cost and actual project cost will be at the conclusion of the project. A negative variance indicates a budget overrun, while a positive variance indicates that the project is expected to come in under budget. The formula for variance at completion is VAR equal BAC minus EAC. In our example at month 3, VAR equal $110,000 minus $126,728.11. VAR equal negative $16,728.11. Based on current performance, our project will run about $17,000 over budget. To complete performance index TCPI. The to complete performance index TCPI tells us what performance must be achieved to meet either the budget at completion or estimate at completion. Whether the performance needed by the TCPI can be achieved depends upon the likelihood of meeting the TCPI throughout the remainder of the project. Based on our sample project, at month 3 we have earned value of $82,500, actual cost of $95,000, budget at completion of $110,000, estimate at completion of $126,728.11. The formula for TCPI to meet the BAC is TCPI equal BAC minus EV divided by BAC minus AC. TCPI equal $110,000 minus $82,500 divided by $110,000 minus $95,000. TCPI equal $27,500 divided by $15,000. TCPI equal 1.83. The formula for TCPI to meet the EAC is TCPI equal BAC minus EV divided by EAC minus AC. TCPI equal $110,000 minus $82,500 divided by $126,728.11 minus $95,000. TCPI equal $27,500 divided by $31,728.11. TCPI equal 0.867. EAC and ETC situational formulas. There are a few situations that can occur on the project which will cause inaccurate measurements if the standard EAC and ETC formulas are used. These situations are based around variances from the project plan, and the variances are either caused by original estimates that were inaccurate or anomalies that have thrown the project schedule or cost off. When large variances do occur, we have 3 ways to deal with them. New estimate. First, we might develop a new estimate to complete that is not based on the ETC formula we saw above. Instead, it's just an updated aggregation of revised activity cost estimates from this point in the project going forward. Atypical variances. Second, We can use alternative ETC formulas if the variances that have occurred are simply so unusual that they are not expected to happen again. Typical variances. Third, there are alternative ETC formulas that we can use if the variances that have occurred are going to be typical for the duration of the project, EAC based on a new estimate. If a new ETC estimate is created, the alternative EAC formula is actual cost plus the new estimate to complete. EAC equal AC plus ETC. ETC based on new estimate. This is just the new estimate to complete based on revised activity cost estimates. There is no formula for ETC based on a new estimate. EAC based on atypical variances. If the variances are not expected to reoccur, then the alternative EAC formula is the actual cost plus the budgeted cost to complete the rest of the project. EAC equal AC plus BAC minus EV. ETC based on atypical variances. This alternate ETC formula uses cumulative earned value. ET equal BAC minus EVC. EAC based on typical variances. When current variances are expected to continue throughout the project, an alternative EAC formula factoring in cumulative CPI is used. EAC equal AC plus BAC minus EV divided by CPIC. ETC based on typical variances. This formula factors in cumulative CPI. ET equal BAC minus EVC divided by CPIC.